On the example 2, we have to identify a linear function using order pairs. Again, the order pair, I'm talking about the part of x and y. This is the order pair I have. So we need to tell whether each of these order pairs satisfies a linear function. And we need to explain why. I have the pairs. So you have the values for the x and you have the values for the y. Remember, you place it on the table. It's easier to work with this if you draw the table representing the values for x and representing the values for y. So for each ordered pair, I take the values. For example, the first one, I have 2 for x and is 4 when I have y. In the next one is 5 for x and 3 for y. 8 for x and 2 again for y. And 11, when you have the last number, is 11 for the x and 1 for y. So how can you know if this is going to satisfy one linear function? You have only one value for y. One value for x, I'm going to place it with one value for y until this point is correct. But what happens next when you have the difference in the y-axis? You can see that the difference is 1. For all the values, when you subtract 1, you obtain the next value. So the function, you have the function is, okay, with a -1. So in this part, y is correct. It's going to satisfy a linear function. But what happened with x? X is changing to, when you add 3 to each value of x, you obtain the next value. So this is going to fit in the, okay, this is going to satisfy, or it's going to fit as a linear function, because you have only 1 point of the x for 1 point of the y. And what else? That is going to be a straight line. The difference is constant, or the sum I have for one value and another is constant too. So this is going to be enough to say that it's going to satisfy my linear function, okay? Because I have the same difference in y and I have the same value to add in x. So in all the points you are going to have for x and y, you are going to have one, okay, the same slope, the same constant of proportionality, but a different, okay, for each different point, you have the same result. So now for the exercise B, you have the same number to add for x. You add 5, you obtain the next number. You add 5 again, you obtain the next number. So it satisfies for x. But what happened with y? With y, it doesn't satisfy, because when you subtract the number minus the number, the previous number, you don't obtain the same. In the first one, you obtain -6, but in the other one, you only obtain -2. So this is not going to satisfy.
Mr. I'm sorry, what page are we?
We are working in the example 2, page 231.
Thank you so much.
231. In the exercise B, you can see that in the part of the y, the difference is not the same. You have -6 in one, and the other one are only -2. So they are different. They don't fit to be a linear function. These points do not satisfy a linear function. Maybe it could be a function because you have only one value of x for one value of y. But remember, the important about the linear function is that you have a straight line, okay? And it's not a vertical or horizontal line. It's a straight line, but it's crossing the part of x and it's crossing through the y. Okay, I think that this example is clear. We can go to the example 3. The example 3 is important because we need to graph. We need to graph the linear function. It's not only about okay, in the linear function, maybe I can explain you if we use, I'm going to try to use the board with you. I'm going to use the board, but the electronic board. Maybe you can see it more in order in here. So what we have on the text, you need to find the values for x and for y, and y is the equation. Remember, you replace the value on the equation. I'm going to move this a little. Okay. So, sorry, it's because I need to move. Okay. You have the equation y equal x plus 3. This is the equation you have in the example 3. This is the example 3. I'm going to write it above. Example. This is the example 3. The x, okay. This is a plus. Y is equal x plus 3. So, you can see in the example, they write the equation in the standard form. This is the standard form. And you can move and you obtain negative x plus y equal 3, but it doesn't make sense because I want to find values for y. And if I want to find values for this variable, I need to have this in the other side of the equation. So if I have this, I'm going to show you the other part. The important part in here is to make the table for the values of y and the values of x. I have y, that y is equal x plus 3. And I'm going to copy the order pair. At the end, when I have everything, I'm going to copy the order pair. I have x, comma, y. This is the order pair. Maybe we can give more space in here. Okay. Now I'm going to start giving random values to x. I want to graph the function. Read that what the example is asking you. We need to know if the function is linear, and if it's a linear function, I want to graph it. How can I know if it's a linear function? I'm going to take values for x, and later I'm going to prove the values for y and see if it have the form or the shape of a linear function. Okay. When you see the order pair, you are going to know it. So for x, for example, I take the first value. I can take negative numbers or positive numbers. In this case, for example, the book starts with 0. You replace in all this, you need to write, for example, that y is equal 0 plus 3. What happened when you have 0 plus 3? Y is equal 3, right? Okay, now in the order pair, I'm going to copy 0 for x, comma, 3 for y. And what happened next? I'm going to take the next value. I'm going to say that x is 1. So I'm going to replace in all the values to obtain the value of y. I replace in all the values of x. So when x is 1, you add 1 plus 3. What happened when you add 1 plus 3? You are going to obtain that y is equal 4. Okay, I copy the procedure so you can see it, but later I erase it and I only have the value. Okay, so I'm going to say again 1 for x and 4 for the value of y. Now, if I take other value, I'm going to take 2 for x. Now, y is going to be, what is going to be? 5, right? Because you have 2 plus 3. So y is going to be 5. This is 1, 1, comma 5. And I already have all the values for this one. It's a linear function. When we plot the points and connect them with a straight line, I'm going to obtain one graph like this. Maybe I can show you.
Sir,
Tell me.
here in the book, it says 2,5 in the last one.
I'm sorry. I write 1 instead of this. Maybe I can replace it. Maybe I can replace this number if I. Okay, imagine it's a 2. I'm sorry, but I cannot erase it once I write. So if I erase, I'm going to erase everything. So I'm going to place the number 2 above. I'm sorry, but it's 2. Now I'm going to show you the graph. If you have, for example, for the values for y and the values for x, and you have in here, this is the value for y and for x, and how is represented in this case? It's represented like a straight line, right? I'm going only to change the color so you can see it better. It starts in here, it starts in here, and it's something like this. So what happens when we have a line that is not completely, for example, if I have one vertical line, this is not a linear function, remember, because I only have one value for x in this point, and I have many values for y because it's vertical. So, and when we have a completely horizontal line, it's not a linear function neither, because you have only one value for y and many values of x. But when we have this kind of arrow, you have different values for x and you have different values for y. I think this is placed in 3 for y, in this point. It's crossing in this point, in 3 for y. But you are taking many points of x. Can you see in here? For example, I'm going to use my hand in there. I'm taking 1 point, one different point, one different point, one different point in here. Can you see it? I have in next many different points, and you know that this continue, right? The arrow is going to continue. It doesn't finish in here. Okay, and now if I take the other part, for example, and I want to know the values for y, you have one different value, one different value. So this kind of graph is a linear function because you have many different values for y and many different values for x. And for one value of x, you are going to have only one value of y. For example, in here, can you see when the points cross? 1 point of x and 1 for y. The same in here, the same in here, in here. Can you see it? Okay, I have 1 point of x for every point of y. I'm going to stop sharing this. So, sorry guys, I take much time that I was planning. I take 3 minutes from your recess, so we are going to continue the class tomorrow. Maybe if you don't have questions about this graph, we can go to another topic, and if you have questions, we can continue, okay? It depends on you tomorrow. And tomorrow I'm going to start the class early. I don't know the schedule, but okay. We lost time today for other things, but tomorrow we continue with all the normality. So have a nice day, guys. I see you tomorrow. Bye.